In the heart of untouched nature, where advanced technology meets the purest natural resources, an extremely precise industrial journey begins. Here, inside one of the world's largest water bottling facilities, we watch groundwater turn into a product that reaches millions of people every day. This plant never sleeps. Machines run around the clock to produce more than 40,000 bottles per hour in a kind of symphony of mechanical engineering and chemical precision that allows no mistakes. At first glance, the process might seem simple. Water goes into a bottle. But the truth is much deeper. It's a complex chain of hundreds of steps that ensures safety, purity, and consistent quality. Everything starts here, hundreds of meters beneath our feet. Mineral water isn't just water. It's liquid geological history. Rainwater that fell decades, maybe even centuries ago, seeped through layers of rock and sand. During its slow journey through the earth, the ground acts like a giant natural filter. And at the same time, the water dissolves essential minerals like calcium, magnesium, and potassium, giving it its unique character. To keep this natural treasure pure, a strict protection zone is set up around the groundwater wells. No farming, industrial activity, or human activity is allowed within the square kilometers surrounding the source. Then the water is drawn from depths that can reach 300 meters using powerful submersible pumps. These pipes are made of medical-grade stainless steel to prevent any chemical reaction or contamination of the raw water. Meanwhile, the pumping process is monitored electronically. Engineers track flow rate and pressure to make sure the aquifer isn't being drained. Sustainability is the key to keeping the plant running for years to come. After that, the water first reaches receiving tanks. Even with its natural purity, it isn't allowed straight into bottles. It has to go through a series of acceptance tests and careful treatment steps. Before treatment begins, immediate samples are taken and analyzed in the lab, where physical and biological properties are checked to confirm they meet strict standards for natural mineral water. Now we move to the beating heart of the plant, the treatment hall. Here, the water is prepared to be completely safe and chemically stable without changing its natural identity, and the process happens in a fully closed system. The first stage is sand filtration. The water passes through multiple layers of graded silica sand and gravel. These layers act like a trap for large suspended impurities that may have been pulled in with the water. As hydraulic pressure pushes the water through forcefully, solid particles and fine, muddy sediments stick to the sand grains, and the water comes out clearer on the other side. When the filter fills up with impurities, the system automatically reverses the water flow to flush out the built-up dirt and clean the sand, bringing the filter back to peak performance. After sand comes the activated carbon stage. This isn't ordinary charcoal. It's carbon processed to massively increase its surface area, so it can absorb any unwanted odors or tastes. On a microscopic level, it works like a chemical sponge, soaking up tiny organic materials or leftover gases that could affect the water's fresh taste. Then comes fine filtration. The water passes through cartridge filters with 5-micron pores. For comparison, a human hair is about 70 microns thick, so anything larger than 5 microns gets trapped here. These filters are replaced on a strict schedule. Technicians monitor the pressure difference before and after the filter. If the difference increases, that means the filter has done its job and is clogged with impurities and needs to be changed. For extra assurance, the water goes through a final polishing stage using 1-micron filters. This step removes microscopic dust and any extremely fine residue that might have slipped through earlier stages. In some cases, groundwater contains a high level of iron or manganese, which can cause discoloration later. So air oxidation is used to turn these dissolved metals into solid deposits. The oxidized water is then passed through special greens, and that traps iron and manganese oxides, ensuring the water in the bottle stays perfectly clear and crystal-like throughout its shelf life. Now we reach the critical disinfection stage. The water enters a stainless steel chamber containing high-intensity ultraviolet lamps. This light is bacteria's #1 enemy. UV, at a specific wavelength, 254 nanometers, penetrates the cell wall of microorganisms and destroys their DNA, preventing them from reproducing and killing them instantly, without chemicals. As an extra line of defense, modern plants use ozone gas. Ozone is generated on-site by a high-voltage electrical discharge that splits oxygen molecules and reforms them. Then ozone is injected into the water at extremely precise concentrations. Ozone is a very powerful oxidizer. It disinfects the water, the bottle, and even the cap. Then it naturally breaks down and turns back into pure oxygen within minutes. Now that the water is pure, disinfected, and still contains its natural minerals, it's stored in large insulated tanks to keep a stable temperature and protect it from any airborne contaminants until the moment of filling. While the water waits, a completely different process starts on the other side of the plant. Bottles aren't purchased ready-made. They're produced here to ensure cleanliness and reduce shipping costs. A bottle begins life as a small piece of PET plastic called a preform. It looks like a test tube. with the neck and cap threads already formed. Thousands of these pieces are dumped into a huge feed hopper, and from there, a mechanical elevator lifts them to the production line, where everything is handled fully automatically. Next, the plastic pieces enter a centrifuge that arranges and orients them so they all stand on their necks, ready to start the heat transformation journey. They enter a linear heating oven and pass in front of rows of infrared lamps that produce intense, precisely directed heat. The secret is evenness. Each piece rotates around its axis as it moves through the heating tunnel, so every millimeter of plastic gets the same amount of heat and softens evenly. But one part must not heat up: the bottleneck. A stream of cold air and metal shields protect the neck and threads from warping, because any distortion means the cap won't seal tightly. At the oven exit, laser sensors measure the plastic temperature, which must be between 100 and 110 degrees Celsius. If it's too cold, it will crack. If it's too hot, it will melt. In a flash, mechanical arms grab the softened pieces and place them into metal molds shaped like the final bottle. In this decisive moment, the mold, made of solid aluminum, closes around the hot piece. The mold is cold and has internal channels where cold water flows to cool the plastic as soon as it touches. At the same time, a metal rod called a stretch rod moves down mechanically to stretch the plastic lengthwise until it reaches the bottom of the mold, ensuring the plastic is distributed along the bottle's length. In sync with the stretching, clean filtered air is pumped in at a huge pressure, up to 40 bar. This air blast forces the flexible plastic to expand sideways and take the mold's shape with extreme precision. The moment the hot plastic touches the mold's cold walls, it hardens instantly, keeping its new shape. This whole sequence, closing, blowing, cooling, takes fractions of a second. Then the mold opens, and the bottle we recognize comes out, clear, strong, and lightweight. It's ejected quickly to make room for the next one, while the machine produces thousands of bottles per hour. Because empty bottles are very light, they aren't moved on regular conveyors where they could fall. Instead, they're hung by their necks on air tracks, pushed by streams of filtered air toward the filling machine. The bottles arrive at the filling room, a clean room with positive air pressure to keep outside dust from getting in. The air here is filtered to a level comparable to surgical operating rooms. Then the bottles enter a mechanical beast called the tri-block, named because it combines 3 operations in one machine: rinsing, filling, and capping, reducing the water's exposure to outside air. First, special grippers flip each bottle upside down over the rinsing nozzles. The goal is to remove any possible dust that may have entered the bottle during blowing or transport. A strong stream of sterilized water or ionized air is injected into the bottle to clean it completely. Then, it's left for a few seconds to drain any remaining drops before returning to its normal position. The clean bottles now move to the rotating filling wheel. Here, the bottle finally meets the water that went through the long treatment process. Stainless steel filling nozzles lower to seal onto the bottleneck, and high-speed filling valves are used to ensure smooth flow and prevent foaming. As the machine rotates, the bottle is filled in less than 2 seconds. The fill level is controlled with millimeter precision using electronic sensors or vent tubes. As soon as the water reaches the set level, the valve closes instantly. Accuracy is essential here. Just a few extra drops in each bottle can mean losing tons of water every year, while underfilling is considered commercial cheating. Without any pause, the filled open bottle moves to the capping unit, the most dangerous stage, because the water is exposed to air, so it has to happen lightning fast. On the upper level, thousands of plastic caps are poured into a vibrating sorting bowl that orients them into a single continuous track leading down to the capping machine. As they travel down, the caps pass through a special sterilization tunnel that sprays them with disinfecting agents or exposes them to intense UV light to kill any bacteria that might be stuck to them before they touch the bottle mouth. Then, magnetic capping heads pick up the caps and place them precisely on the bottles, moving underneath at high speed. Rotating heads twist the cap with a precisely set torque, tight enough to prevent leaks and retain gases, ozone, but not so tight that the consumer can't open it. Now, the bottle is sealed and safe. It leaves the isolated room and begins the identity and packaging journey. It's no longer just a bottle of water, but a finished product that needs a name. As soon as they exit, bottles pass in front of smart sensing cameras. These cameras check the fill level, the presence of the cap, and whether it's tilted. Any bottle with even a slight defect is rejected immediately. With a precise airburst or a mechanical arm, any questionable bottle is diverted into a recycling container, ensuring only perfection reaches the customer. Then the bottles reach the labeling machine. Here, there's a huge roll holding thousands of printed labels with the company logo and product information. A heated cylinder places tiny dots of hot melt glue on both ends of the label, and the glue must dry fast and resist moisture and cold. As the bottle rotates, the label is pulled and wrapped tightly around it, while a soft brush smooths it down to ensure there are no air bubbles underneath. After that comes the most important legal step, printing the production date, expiration date, and batch number. This is done using laser printers that etch the information onto the plastic or high-speed inkjet printers. These numbers are the bottle's identity, and if there's ever a complaint, the plant can trace that bottle to know when it was made. The individual bottles are now gathered and start lining up in multiple lanes, getting ready for the group packaging stage. The speed slows down a bit here to allow things to be organized. A dividing machine separates groups of 6 or 12 bottles, and each group is wrapped in a layer of clear, shrink plastic film. Then, the loosely wrapped bundles enter a hot heat tunnel, and the hot air currents inside make the plastic shrink and tighten around the bottles. The packs come out the other end firm and strong, ready to handle and transport, and they're cooled with air fans to set the plastic in its new shape. Some machines add a strong adhesive strip that works as a carrying handle, making it easier for the customer to take it from the store to home. And we've reached the end, where a huge robotic arm, precisely programmed, picks up the packs and stacks them in a specific geometric pattern on a wooden pallet to keep them balanced and prevent them from falling. As the stack gets higher, the robot places a layer of thick cardboard to spread the weight and protect the bottles in the lower layers from the massive pressure. Then, the completed pallet moves to the final wrapping machine, where the pallet spins while an arm wraps it with multiple layers of stretch plastic to secure the whole load as one solid block. An ID label with a barcode is placed on the pallet, and this barcode tells the warehouse system what the shipment contains and where it's going. Meanwhile, skilled forklift drivers move the heavy pallets quickly and accurately to the temporary storage area or straight to the loading docks. The warehouse looks like a city of water, with thousands of tons stored neatly in a clean, cool environment away from direct sunlight to maintain the quality of the plastic and the water. Outside, a fleet of trucks is waiting, and the pallets are carefully loaded into closed trailers. Logistics here are just as important as production. After that, the truck doors close and the distribution trip begins. This water will travel hundreds of kilometers to reach cities, villages, supermarkets, and restaurants, until the journey reaches its second-to-last stop, store shelves, where the shiny bottles are displayed under the lights, waiting for the hand that will reach for them. In the end, the bottle reaches the consumer's hand. You hear the sound of the cap being opened, and pure water flows to quench thirst and bring the body back to life. Every sip is the result of a long journey from deep underground through complex technology and countless tests to reach you pure and safe. And the story doesn't end here. The empty bottles can be fully recycled to become new products, closing the loop and protecting the environment. From underground rocks to filters to blowing and filling, this is the amazing story and the precise science behind the mineral water bottle we carry every day.